Okay, so when you go into new document, oops, you can't read that. Up in the top corner here, it should say degree. When you go into a new document, make sure it says degree. If your calculator is not in degrees and you don't check it right now and you're like later, Miss, my calculator's not doing the right thing, I'm gonna be really mad at you. Like, really mad. Okay, make sure this says degree. Anybody's not say degree?
How do I change it?
Okay, how do you change it? Great. Go to the home button. And you're gonna go to the settings, which is number 5. Settings. And you're going to do the document settings, which is number 2. And then the second thing down should say degrees instead of radians. So just click on that or do the side arrow and you can change from radians to degrees. And then once you're done, you go down here to the bottom to make default and it will stay that way. Okay. And then when you go into your new document, it should say degree up in the corner. Yeah. On some of them, like some of the newer ones, you can actually just click, like use the little cursor and you can click on it sometimes to change it. Mine won't let me do that. Some of them will allow that, which is kind of a shortcut, but this one doesn't. All right. Are you good? Everybody good? In degree? Awesome. Are you good, Vim? What's wrong with that other one?
Oh no, it just needed a battery.
Oh, okay.
Is it where?
Home.
Oh, it does. Never mind.
All right, so we are going to review. This is geometry. In geometry, we usually spend about a week going over how to find a side length, how to find an angle measure, how to do angle of elevation, draw the picture. We're doing it in one day because you've already learned it. We just need to remember it. Okay, SOHCAHTOA. You need that, so you need to remember which ratio you're using on your picture. Okay. When we are solving our equation, I sort of wish I had my poster up still, but I don't teach geometry anymore. I don't know where my poster went. Hi. Oh, y'all are cute. I miss y'all. Okay. Good to see you. All right, so sometimes, like, you're going to write your ratio, like, it's going to say, like, sine of 37 degrees equals x over 12, right? Whatever our trig ratio is, the angle measure, and then sine is opposite over hypotenuse, and you plug the numbers in, right? Sometimes it might say cosine of 37 equals 12 over x, right? I'm just making things up. Okay, so notice the difference on this one. We're using cosine instead of sine. So this is adjacent side of 12, and this hypotenuse is the side that we don't know, right? The other way that we could have our problem is our x or our missing value could be where the angle is. And then we have numbers for both of these, like 8 over 5 or whatever the numbers are, right? It doesn't really matter. Okay, so do you see where the missing value is on each of these? Okay, so what we learned in geometry is that when x is on top, we're going to multiply. Okay, 12 times sine 37. Start with the number here, 12 times all of that. It's like a cross multiply, right? We can cross multiply, these are diagonal from each other, we just multiply them together. Okay, on this one, when x is on the bottom, we are going to divide. So we're going to start with the 12 and we're going to do 12 divided by cosine 37. Type, hit enter, it gives us an answer. Right? So when you have x in your fraction, you're either going to multiply or divide depending on whether x is on top or the bottom. When x is your angle or your missing value is your angle, you're going to use the inverse, which is that -1. Sine -1, cosine -1, tangent -1. It'll look like this. And then it gives you a parenthesis where you can just write or type that fraction, like whatever that is going to go inside there. It's not a tan to the -1 power. It's tan -1. So on your calculator where it has the trig button over here by the 7, okay, when you push that button, it opens up and it has, oh, this is so hard. Hold on, let me make this darker. Okay, so this is the inverse. Sine -1 is the inverse of sine. Okay, so cosine -1. So for this problem, I would do tan -1, and it shows us that. And then inside there, we're just going to put the fraction 8 divided by 5, and then that becomes the angle, right? So remember, when you're doing the angle, this is the one of the angles in a right triangle. So this number should be somewhere between 0 and 90, right?
So are we finding angle measures?
We will be finding angle measures sometimes. We're going to find sides and angles as needed. Okay, so that's the process. Like, that was like 3 days worth of trig right there. Okay, so let's do a few problems. We're not going to do all of these. Let's just look. Okay, let's start with number 1. So it says find the value of x, round to the nearest 10th. So that's going to be 1 decimal. Right, one number after the decimal. Okay, so we always start with the right angle. So this is a right triangle. We have our angle here, 32. We're going to go across from that. So this 11 is going to be the opposite side. I don't have to label all of the sides because one of the sides doesn't have anything on it, right? So I don't really care about that side, but I care about this x. So this x is going to be which other side? Hypotenuse. So once I have that labeled, then I know which trig ratio we're going to use. So in this problem, we have O and H. Which trig ratio uses O and H? Thank you for saying sine. Sin is bad. So sine is opposite over hypotenuse. So for this problem, we're going to use sine of our angle. And the angle in this problem is 32 degrees. And then we have our equal sign. And then we're going to do the ratio. The ratio for sine is opposite goes on top. Opposite was 11. Hypotenuse goes on the bottom. X is down there. Okay, so this problem is going to be divide. So in my calculator, we're going to type 11 divided by sine 32. Start with the 11, divide by the whole trig ratio. Sine 32 goes together. You're never going to split those. You can't type it as just 32. It all stays in there. So 11 divide sine 32 makes 20.8.
Yeah.
Which would make sense that the longer side of this triangle is 20, where the shorter side is 11, right? If you did all of that work, like say you accidentally multiplied, and you're like, oh, I messed up. If you accidentally multiplied, you would get 5.8, and your brain should go, something's wrong. Like that hypotenuse can't be 5 when the other side's 11. Okay. All right, let's pick another one. Somebody pick one of these. Which one looks? 3. So number 3 is a little weird because their font was too big. They couldn't squish the 23 in there, right? So what I would do is I would just literally write the 23 in there on my own, and then you don't want it on the outside because sometimes that gets a little confusing. Or you can color in the angle or whatever. Okay, so we have the angle here. Let's see, we don't have the opposite, so we're not worried about that. So that makes the x the adjacent side, and the 30 is across from the right angle, so that's going to be the hypotenuse. So this one now has A and H. So which of our trig ratios has A and H? Cosine? Cosine. And then once we write that down, then we write the angle. So it's always the trig ratio of the angle, 23 degrees, equals fraction A goes on top, which is going to be the x, and the hypotenuse goes on the bottom, which is 30. Okay. So the process of getting to this point is the same for every picture, right? Find the angle that they give you, label the sides, pick your trig ratio, write it out, okay? Then you decide how to solve it, okay? And please don't try to skip this step. Like, this has to be written on your paper, right? So now x is on top. So if x is on top, we're going to multiply. So which number are we going to put first in our calculator? Just for our notes. Like, you don't have to write it down later, like, just right now. We're going to start with the 30, and then we're going to multiply that by cosine 23. Just so that when you look back at it later and you're like, how did we get 82? Like, or whatever the number is. 30 times cosine 23. Oops. 27.6. Okay. How about, can you do number 4? And then we'll move to the next part. All right. Sine, cosine, or tangent? Tangent. I agree. So which goes on top? 15 over x or x over 15? Opposite goes on top? Okay. So make sure you're using the ratio to determine where the number and the x go. It's not x is always on top or x is always on bottom. That doesn't work. Okay, so if x is on the bottom, then we're going to divide. $17.3. Do you feel smart? Do you remember that? No, you don't remember trig? You must not have had a great geometry teacher, right?
And Trauma left midway through the year.
Oh, yeah. Don't remind me. So you had Miss Clueworth. And you didn't watch any of my videos. You could have learned from me, Alina. You did? Okay. All right. This is the we don't need to do this. This is the solving for the angle. So let's just we could do both of these. Yeah. Okay. So on this one, they don't give us a number here, but this is still the angle. Do you see how there's nothing up here in this one? We don't use that. The right angle is always going to be there. So we're using this angle to label our triangle. So the opposite is going to be this side over here where there's nothing. So we don't need to write that down. So the 18 is going to be adjacent and the 23 is hypotenuse. So this one has an A and an H. Which ratio uses A and H? Cosine. So after cosine goes the angle. So what's the angle in this problem? X. You can put X or you can put theta, whichever one makes you happy. It's the same thing, either one. Okay, that's going to be our angle. And then our ratio for cosine is adjacent over hypotenuse. So adjacent will be 18, hypotenuse is 23. Just a side note on sine and cosine, it's always something over the hypotenuse, which always is the biggest side, right? So when you're doing sine and cosine, you always have to have your bigger value in the denominator. If you don't, it's going to give you an error when you type it into your calculator, and all sorts of weird things will happen. Tangent is the only one where it doesn't matter. Like the two sides will switch depending on which one's longer or shorter, the two edges. Okay? All right, so here when we're solving for theta, in our calculator, this is where we use the inverse, and we just say, it says right here, we're just going to read it as inverse sine or inverse cosine. Like we don't really have like an abbreviation for that. Okay, so we're going to do cosine to the -1, which is inverse cosine, and then it'll open up a parenthesis, and inside that parenthesis, we just put the 18 divided by 23. So inverse cosine, so down to the bottom row, inverse cosine 18 divide 23. And you could put it in as a fraction, or you can just use the divide button. It doesn't really matter. And then when I hit enter, this should give me an angle. So it shouldn't be like 5, right? Unless, I mean, it happens. Like airplanes take off at really, really small angles, right? Like when an airplane takes off, it only goes up a little tiny bit. It's not going to be like 70-degree angle. Like that would hurt people. So in real world scenarios, sometimes when we're talking about really, really long distances, like miles and miles and miles, we might have super tiny angles. When we're talking about this, it's probably not likely that our angle is going to be like a half of a degree or anything like that, but you never know. 38.5, round to the nearest tenth still. Bless you. 38.5%. Okay. Let's turn the page. Let's pick one on the top of the next page. Do one more with an angle. What number?
12.
What? I'm going to turn the page. We're going to do one of these. I heard 12. Let's not do 12 because it's cosine as well. Let's do one that is not cosine. Okay. 11. All right, 11. Ready, set, go. Solve for the angle. Vivian, did you have a great geometry teacher? Yeah. I know he was.
When we did the previous one, it turned out different. I don't know if that should make it a big deal or not, but it gave me all that.
Oh, because you have extra numbers, but when you round it, it's still going to be 0.5.
Okay, so he
I
said-
wonder why. Yours might be set on having like all sorts of extra numbers. Let's see. Oh, yours is on float. Mine's probably on fix. It's fine.
Okay.
Yeah.
All right, so
No worries.
it's not a big deal.
Yeah. No, it would be fine. All right, 11. What ratio are we going to use? Do you say that just so I'll look at you? O and H is sine. We don't know the angle. Opposite, 29 on top. So we're going to do sine, or inverse sine of 29 over 52, which makes what? 33.9? Do I believe you? Okay. So, any questions? Okay. Well, no. Okay. So the next part says solve each triangle. So round all measures to the nearest tenth. So on this triangle, when it says solve for the triangle, it means you're going to find all the sides and all the angles. Like everything that's not already listed. Okay? So on this problem, we already have the 90 degrees here, so we don't have to worry about that because that's already there. We have one angle that's 72. We are missing angle B. Okay? Tell me what you know about the three angles in a triangle. They have to add up to 180 degrees. So if we already have two of them, I don't have to do any fancy trig. I'm just going to add those two together. 72 plus 90. Oops, just kidding. That's not a 72. 72 plus 90, which makes 162. And subtract that from 180. And we're left with 18. Okay. Your other rule is that if one of the angles is already 90 degrees, then the other two have to make the other 90. So you could just subtract 90 minus 72 and it would give you 18 as well, right? I sort of prefer all three angles add up to 180. That's an easy rule to remember for me. Okay, so that's going to be like step one if you can do that right away. So angle B is already 18 degrees. So we have that. Now we got to find the other two sides. Okay. So we have a couple choices. Okay. So choice number one is, well, obviously we have to use this side that's already given. Got to use that one. Okay. And then we're going to figure out one of the other sides. So you can choose which side you want to do next. Somebody pick one. Left? That is left. Okay, we're going to solve for this one, which is AB. All right. So the 15, well, again, choices. Do you want to use the 72 degree angle or do you want to use the 18 degree angle? It doesn't matter which one we use. If we use the 18, then this 15 is going to be opposite and this is going to be hypotenuse and we're going to use sine, right? If I use the 72, then this 15 is right beside it. That's going to be adjacent and hypotenuse, and then we're going to use cosine. But it's going to give us the same answer either way. It doesn't matter. You just got to pick one. So I'm going to circle. Which one do you want me to circle? 18. So I'm going to circle this angle, and I'm going to use this to label my triangle. So then across here, this 15 is going to become opposite, and AB is our hypotenuse. So O and H is going to be sine. Sine. The angle we circled so we don't get mixed up and we don't put the wrong number. So sine of 18 equals, O goes on top, 15. And then the bottom, I'm just going to go ahead and write that as AB. So I don't have to worry about like X's and Y's and all the things. Like that's just the side that we're still trying to find. Okay, so if I want to find that side AB, it's on the bottom. So are we going to multiply or divide? We're going to divide. Do I need to write that down? Are you okay with doing that part in your calculator now? Okay, 15 divided by sine 18. 15 divide sine 18. 48.5. Yeah. So AB is 48.5. So once I know that, I should probably write it back into the picture. That was a big thing in geometry, right? As you're solving parts of the problem, write down what you figure out. So now we know that this side is 48.5 and we have another side of 15. So you could do another trig, right? Like I could use this 18 and I could use adjacent over hypotenuse, or I could use adjacent over opposite. Like I could sort of do whichever one I wanted. Or we could do Pythagorean theorem, right? A squared, B squared, C squared. I already have two sides. So the third side is going to be the square root of the biggest number first, 48.5 squared, 15 squared. Do I want this to be bigger than the 48 or smaller? Smaller, so it's going to be minus. And then I don't have to really worry about the trig. But this has lots of room for you could do your work different ways. So if every single person turns in their work with all of the exact same methods, I might be suspicious. Just saying. 48.5 squared minus 15 squared. What'd you forget? Square. 46.1. Okay. just for sake of showing you, okay, if I did this side as the adjacent, I could use adjacent and opposite. That would be tangent, right? Adjacent and opposite is tangent. So tangent of the 18-degree angle is opposite over adjacent. So this is BC. What we're trying to find is on the bottom. So am I going to multiply or divide? Divide. 15 divide tan 18. It should be 46.1. Yeah? See that same thing? Okay, so you got options. I know sometimes in life we don't like to have options, but let's go down here to 15 or 16. Let's pick one of these. 16, yeah. All right, so on number 16, we've already got our right angle, and we have two sides this time. So what should I start with? We could do Pythagorean theorem to find the third side. Sure. Okay, 22.5 squared, 21 squared. Do we want that side that we're finding to be bigger or smaller? Smaller than what?
22.5.
This one's the right angle. This is our hypotenuse. This has to be the biggest one. The two sides that touch the right angle, those are always the two little sides. Those are called the legs. And then the hypotenuse is the biggest one that doesn't touch the right angle. So square root 22.5 squared plus 21 squared. 30.8. All right, so we got that side. Again, label it in your triangle as well as putting it over here. So we already know that. Now we got to find one of these angles. Which letter, Sophia, which letter do you like better, D or F? You are not Sophia. D. Awesome. So we're going to solve for D first. So we're going to put theta right here. And we're going to use trig. When we use trig, we need two sides. You can pick whichever two sides you want. Whichever two that make you happy. Label those two. Okay? Personally, I like opposite and adjacent. Just for right now. I don't know why. Whatever. Okay? But I only need two of them. I don't need three because my trig ratio only uses two sides at a time. So I'm going to pretend that this 30.8 isn't here. I have a 22.5 and a 21. Sometimes it's good to go back to the original problem, like what numbers were there, just in case we messed up here, right? So I try, like, as I'm working problems, if I can help it, I try not to use my new numbers just in case I messed up because, human makes mistakes. All right, so on this side, this is going to be O and A. That's going to be tangent, right? So tangent of theta, opposite 22.5 over 21. When we're finding the angle, we use the inverse tan. 22.5 over 21. Which equals 47.0. Yep. Okay, so rounding purposes, because I know some of y'all got really frustrated on the Delta math, which is still due by Friday. Hint, hint, wink, wink. Okay. When you're rounding here, if the directions say round to the tenths, that means every single answer needs to have a tenths place, right? Even if it becomes a 0 like this, the 7 makes the 9 into a 10. Okay. All right, so angle D is now 47.0 degrees. And what do we know about these two angles in our right triangle? There are only two of them. They're not going to add up to 180. 3 angles add up to 180. So these two are just going to make 180. What's the other angle already? This other angle is already 90. So if we get the 90 out of the way, then the other two have to make the other 90. That's called complementary versus supplementary. Yeah? So these have to equal 90 degrees. When you have two angles of your right triangle, they have to add up to, and you said 43, right? Like you did the right work. You already did it. Okay, so 90 take away 47 makes 43. Okay. So, free thought on how you want to solve those. You have a little bit of a roadmap. Okay, angle of elevation and angle of depression. No, nice try. All right, so the most important thing with angle of elevation and depression is that the angle starts from your natural line of sight. Okay, I don't know why they call this the line of sight going up here. Okay, this start is your natural line of sight is always your horizontal line. Okay, coming out of the eyeballs to start with, then your line of sight either goes up or down from there. Okay, so on an angle of elevation, you're always going to have a horizontal line at the bottom of your picture, and then your triangle is going to go up from there. Elevate goes higher, right? Okay, so let's draw a couple pictures. Okay, we don't really need to solve these. Once we have the picture drawn, then like the math is the same as what we had before. Okay, a fire started at a campsite 8 miles from the base of a mountain. Angle of elevation from the fire to the top of the mountain is 14 degrees. Okay, so down here on the ground, there's a fire. Here's my fire. Okay, if you can't tell what that is, then you're going to put a dot and you're going to write fire. Like it's okay. It doesn't have to be fancy. And then we have our mountain. Okay, here's our mountain. Snow-capped peak. Isn't that beautiful? Right? Okay. Or you can draw a straight line that goes up from the bottom of the mountain to the top of the mountain. And you can label it mountain. Like, whatever. Okay. So a fire started at a campsite 8 miles from the base, from the bottom of the mountain all the way over to the fire is 8 miles. The angle of elevation, so from the fire, this is our horizontal line going out first, and then from there it's going to go up to the top of the mountain, elevate, and that angle is 14 degrees. How high is the mountain? X. Where's the right angle go? At the base of the mountain, between the mountain and the ground. Okay, how tall is the mountain? So on this problem, if I were to label this now, we've got our 14 degrees here. The X is opposite, and the 8 is adjacent, which means we're going to use O and A is tangent. Oh, A, not H. Tangent of 14 equals O over A, X over 8. Type, blah, 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 answer. Right? Multiply, do the things. Okay, let's pick another one.
6.
Let's not do 6 yet.
4.
4. Lana's kite is flying 60 feet above the ground. The angle of elevation from where her hand is holding the string to the top of the kite is 14 degrees, 18 minutes. 14 degrees, 18 minutes. So we have to change that into a decimal first before we type that into our problem. So we'll do that in just a second. Her hand is 5 feet from the ground. Find the length of the string. Okay, so here's Lana. Hi, Lana. You're beautiful. My people's arms are never attached properly. That's okay. Okay, here's Lana. She has a kite in her hand. So the string goes like this, up to a kite. And you can make your kite look like a dragon. You can make it look like a hot air balloon. You can make it look like whatever kind of kite you want. However much time you want to spend. Or you can make it a dot and say kite. Because that's okay too. Okay? So the most important thing with angle of elevation is that from where the angle starts, we have to have a horizontal line. So this kite is where her hand is starting our angle, and it's going to be like this, parallel to the ground to directly underneath the kite. That's where our triangle is going to be. Okay? Because I can't have an angle from the ground all the way up to her hand. That wouldn't make sense, right? So this is going to be our angle of elevation, which is the 48 degrees, 18 minutes. The kite is 60 feet above the ground. Okay, see this bit right here? See how it's not part of my triangle? How long is that little piece? 5 feet? Because it says her hand is 5 feet above the ground. So if the kite all the way down to the ground is 60, what's the side of our triangle going to be? 55. Because we're going to get rid of this little bit since it's up off the ground. Find the length of the string. The string goes from her hand to the kite, right? This is the string. So this is our X that we're trying to find. So this is going to be opposite over hypotenuse, which is sine. Sine of our angle equals opposite over hypotenuse, 55 over X. So, before we go away from this, how do we put this? Like, I can't type that into my calculator. 48 degrees, 18 minutes. Do you remember how to change that? No. I'm looking back in my notes. Degrees, minutes. To decimal. The minutes is divided by 60. And then if there are seconds, we divide that by 3,600. But there aren't in this problem. So we just need to do whatever that number was divided by 60. So 18 divided by 60. We need it as a decimal. Point what? 0.3. So this angle is going to be 48.3 degrees. Yeah? 48.3, and then we could type the things into our calculator and do what we need to do. Yeah? All right. Man standing at the base of a tower, ladder resting along a wall, or ramp being built. Do y'all know what ramps are? Mr. Reader was very shocked. His geometry class didn't know what a ramp was. Is that not a common word that we use anymore? Yeah? Okay, let's do number 3. A 32-foot tall ladder rests against a vertical wall. Okay, vertical means like this. Here's the wall, right? Wall. Make it the side of a building if you want to be fancy. And the ladder is resting against it. Okay? Ladder safety. Ladders never go vertically. Otherwise, when you climb it, it will fall and you'll plummet to your death. So don't do that. Okay? So we have a 32-foot ladder resting against the wall. The top of the ladder, way up here at the very top, reaches a point 18 feet up the wall. So from here all the way down to the ground is 18 feet. What angle does the bottom of the ladder make with the ground? So that's this angle down here. We have our right angle where the ground and the wall meet. So we're trying to find the angle. Yep. So the 18 is opposite, and the 32 is the hypotenuse. So that's going to be sine again. So sine of our angle is opposite over hypotenuse. Do the things, whatever, right? Like this, solving them is the same after that. Yep. All right, let's look at number 6, and then we'll do some depression. Okay, so why would I want to do number 6? Because you hate us, miss? No, not because of that. Because what? Because there are 2 kids, and there are 3 numbers, right? Okay, so Sarah is standing 35 feet from the base of a rock wall, watching her 2 sons, Max and John, climb the wall. So the angle of elevation to Max is 38 degrees, and to John, it's 27 degrees. How many feet above John is Max? Or how far are the 2 boys apart from each other, right? Okay, so here's Mom. She's down here on the ground watching, right? This is Mom. Okay? Poor thing, exactly. Like the things that we do as parents. So she's level with the ground, or level with the base, not necessarily the ground, but level with the base of the climbing wall. Okay? And so here's the wall. And let's see. Which boy is higher up? The bigger the angle of elevation, is that going to make it go higher or lower? Higher. So Max is going to be higher. So we're going to put Max all the way up here at the top. So this is Max. And then, so from this is all 38 degrees for all of that. And then we're going to have a little shorter. We'll make it down here. It's probably way too much, but that's okay. This is going to be John. And in between these is 27. Okay? All right, so we have 2 separate problems. Wait, do we have one more number? Oh, I missed a number. Where's the 35 go? down here at the bottom. Between her and the wall is 35 feet. Okay, so I'm going to use my colors because I can. Do you see this little triangle right here? Okay, I can solve this to figure out how far John is from the ground, right? This lower triangle. It has an angle of 27. It has a 35 down here at the bottom, and it has a side that we're trying to find that's x. Okay, is that going to be sine, cosine, or tangent? This is tangent because we have the two legs. So tangent of 27 equals x over 35. Okay, here's the problem. Do you see this little triangle that's uncolored right here? I could figure out how big this angle is, right? By subtracting these two. This would be what, 11 degrees? Do you see a right angle anywhere in that triangle? No. So I can't just use this triangle by itself, because ultimately, like, we want to know how long this is just right here, right? How far between them. So I can't do that. But what I can do is I can just do the same thing for this bigger triangle with Max. Like, pretend Max was climbing by himself. How far up the wall did Max go? This is just a big triangle. Okay, so we're going to find all of this from the ground all the way up to where Max is, and maybe we'll call that a different letter. So instead of X, you could call it Y, or you could call it A and B, or you could call it whatever, make up random symbols. Okay, and this one has an angle of 38, but the triangle is set up the same. It's still tangent. The angle is 38, and it's still however far he is up the wall over 55. Okay, and then we get those two answers, and once we have the two answers, then we can subtract them, right? When we're done. Oh, sorry, 35, my bad. I can't read my writing. Okay, and then subtract when we're done, right? Blah, 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 answer. Okay, all right, let's do maybe 2 angle of depression. I don't know, what do we got here? So on your angle of depression, your horizontal line is going to be up at the top of your triangle, and your angle is going to go down from there, right? Depression is down. All right, let's see. Lighthouse, helicopter, tree, wire. What do you think? Ooh, we should draw a deer. Can y'all draw a deer? Have y'all ever played Pictionary? Do you know what it is? So I was playing Pictionary with my brother and sister when we were little, and I had to draw a deer. And it looked like, he's like, dinosaur? I'm like, no. He's literally teased me about it my entire life, that my deer looked like a dinosaur. I cannot draw very well. I bet I could do an awesome deer right now. Henry is sitting in a tree 32 feet above the ground, watching a deer. Which side of the paper do you want me to draw the tree on?
Whatever side.
Okay, tree's going over here. This is my go-to tree. Okay, Henry is in the tree. So here's Henry. He's just chilling. Looks like he's standing. Let's make him sit. Okay. This is Henry. Don't die, Henry. Okay. So from Henry down to the ground is 32 feet. Okay. And then over here, he sees a deer. Wait, they have tails like that. Looks like your mom. It does not have a long enough neck to be a giraffe. Whatever. Deer. Y'all judgy people. Okay, that's okay. Mine doesn't either. Okay, the deer is standing 57 feet from the base of the tree. Find the angle of elevation. No, just kidding. Angle of depression from Henry to the deer. So here's the problem. Here's how everybody always messes up. They do this, right? You see that triangle? Okay, this is an angle of elevation if the deer was looking up at Henry. We don't want that triangle. We want Henry to look out from the tree, and he's like, doo-doo-doo, and he's looking around straight out from the tree, and then he looks down and sees the deer, right? So the triangle is going to be this sort of upside down triangle at the top here. And then we can bring the 57 from down here at the bottom up to the top. And we can bring the 32 over here to this side from the height of the tree, or how high he is. Okay, and then we're solving for the angle there. Okay, so just make sure that your angle of depression always goes down from a horizontal line. Solve, think. My husband just went to the doctor because his cough is up. I don't know, does it hurt when you cough? No? Okay. Mine went away really fast. It didn't go away. Just saying. Okay. Let's do one more. Let's do the lighthouse. The top of a lighthouse is 150 feet above sea level. Okay, so the lighthouse is always up on a cliff, right? So here's the cliff. Here's the water down here. Okay, and then we have this lighthouse up here. And it has a light on it that's shining for all the world to see. Lighthouses have these like candy cane stripes on them, right? That's my lighthouse. Don't hate. It's not bad. It's not bad. Whatever. Okay, from the top of the lighthouse, 150 feet above the sea level. So from the sea all the way up to the very top of the lighthouse, all of this is 150 feet. All the way to the top. The angle of depression. So there's a person up here in this lighthouse. And where are they looking? Not yet. Where do they look first? Before they look down, they're just like, doo-doo-doo, looking around. And they're like, hey, look straight out here. And then they're going to look down like this. And they're going to see a boat. And it makes a triangle like that. So this angle of depression going down is 28 degrees. This height is 150 from the top of the triangle down to the boat. And what are we trying to find? What is the horizontal distance from the boat to the base of the lighthouse? That's this piece down here, which would go up here at the top. Okay. If it said, how far from the person in the lighthouse to the boat, right? Like that distance would be this diagonal, right? Like between the two pieces or between the people. Okay, so again, the thing that's going to make, well, one, drawing your own pictures is always a challenge, okay? I remember that from geometry. We had issues with drawing the picture and understanding what the words were saying. So ask questions, ask for help, it's fine. Okay, the things that are going to make the pre-cal questions more challenging would be something like this, right? So if I wanted to type that into my calculator, it's going to be 34 point something degrees, right? So to change it, what are we going to do with the 54? Divide it by 60, and we'll get a number. And then what are we going to do with the 8? Divide it by 3600, get both of those, add them together, right? To have our decimal, I would probably do 4 decimal places so that it's a little bit more accurate for our final answer. So this is 0.9, that's not very many decimals. And this one is 0.0022. So that's going to be 0.9022, right? Add those together. Okay, and then do the things, right? And then the other thing that will make this a little bit more of a challenge is like with Max and his brother, like you have two different problems and you're sort of solving for that. So this is sort of the same thing. We have a scuba diver with a shipwreck. Okay, so he's like, okay, so if I remember this, so here's our scuba diver. Okay, this is the person. He's like swimming along in the ocean, like this is his body, right? Okay, and he's gonna look down. He looks this way, and then he looks down, and he sees the shipwreck, right? This is the old boat down here at the bottom of the ground, or the bottom of the ocean. And then when he looks up, he sees his boat up at the top of the water, right? Do you see the two triangles? Okay, so these are both right triangles, so we could find how far he was to there, how far he was to there, and we could find this whole like depth thing, right? So it's just a matter of sort of understanding what the picture is giving and what parts you're trying to find. Okay, so again, this is just review. Then we're gonna move into like actually doing the new stuff with Trig. Okay, have y'all done